So now can we continue the lecture? Yeah, just before the lecture, I got a call. Anyway, so let's proceed forward. So far is good. Actually, I come from industry background. So when I start speaking on this topic, I can keep on talking long and long and long. You might have noticed on certain topic, I keep talking as if I have been working on it for many, many years. So let's proceed. So what is Hadoop? So Hadoop is basically a distributed computing architecture or an ecosystem. So if someone say, is Hadoop a software? We install it as a software, but practically Hadoop is not a software. It is an ecosystem. It is a framework for distributed computing and distributed data processing. So in Hadoop, very basic thing is there. There are only two important thing is there. In Hadoop is many clusters are there, and among them, one will be the master cluster or master node, and other will be the data node. So master node is known as name node, and data node is known as data node. And this master node, so basically Hadoop is a master and slave architecture. And in normally, if it is a small size Hadoop cluster, there will be around hundreds of system, means small Hadoop cluster, 100 servers are there. And those are actually commodities server, not IBM or this kind of thing. So a master system will be there, and data will be stored in the data node, and the master node will have information about where the data are kept. Now, if you think about, let's say you have an MP3 file, movie file, audio file, MP3, and its size is, let's say, 1 MB. So let's say 100 KB. Let's say you have an MP3 file of 100 KB, and you want to store in your computer. It can be a Windows system, it can be a Linux system. So do you think your computer will store this 100 KB of file as it is? Means at one place, I mean to say. Any response? No response. Anyway, so in Ubuntu or in Windows, the block size, there is a concept called block size. A data will be stored in a size of a block, and the size of a block in a Ubuntu system, especially a ext4 system, is 4 kilobyte to 8 kilobyte, and Windows also 4 kilobyte to 8 kilobyte. So if you have a 100 kilobyte of simple MP3 data, or even 20 kilobyte small tiny images, that will also be not stored in one place. It will be stored in a, let's say if it's 20 kilobyte and our block size is 4 kilobyte, then it will be stored in 5 different places. Along with, there will be another place where the information about where those 5 places are there, like a lookup table, that information will be there. So basically in 6 places, your will require 6 block size will require to keep only 20 kilobyte of data. In Hadoop, this 4 kilobyte requirement block size is actually now bigger. So in Hadoop, the default block size is 128 megabyte. And that's you can understand that this is to handle the big data system. So 128 megabyte of block. So if you have a file of 100 megabyte or 120 megabyte, it can be stored in one block. But if we have a movie of, let's say, 2 gigabyte, and we want to store it in a Hadoop, then it has to be distributed in a different Hadoop cluster. An industry nowadays can generate, as I was saying you earlier, like Uber is generating 100 terabytes of data in a day. I work in my lab has a system where it generates the image. It can generate every second 100 gigabyte of data, but we are actually not storing them. If we want to store, every second 100 gigabyte will be stored. So you can understand in 5 seconds or 10 seconds, it will be 1 terabyte data is getting stored. So there are certain business, and that is only one microscope I'm talking about. So there are companies where they're generating lots of data. So this Hadoop kind of platform actually helpful, where your data is stored in a distributed way, and then processing can be done. Now, in a Hadoop, okay, Hadoop is basically a framework, not a software. And in this, dynamically, we can add or remove machine without having any downtime. So let's say we have a Hadoop cluster, and which has, let's say, I have shown you a 4 node cluster. Let's say we have 100 node cluster, and if you want to make it 200 node cluster, we don't have to shut any of this machine or even the master node. We can add the 100 more nodes in this Hadoop, and without a downtime, it can be 200 nodes. So it is a very high availability system. Like we can have a 30,000 machine also. When we go more than 5,000, there is some additional thing requirement comes up, like federation comes up, means up to 5,000 machine, one master node can handle. But if we go more than 5,000 machine, then multiple master node will be needed, and then federation of master node kind of technology is needed. So let's not go to that big. If we have, let's say, 100, 200, 1,000 machine, for that, this master and slave architecture is there. So it can scale out architecture. Let's say you have been asked that, okay, we want some system, or we have to handle a scenario where the requirement is that the data will grow up and we do not want any downtime, and we want everything in private network. Okay, means in-house. So in that scenario, let's say a company has running with 50 server, and then it want to go more. Definitely it has to be installed in Hadoop. Then Hadoop kind of framework will be there. Then 50 more nodes can be added without stopping anything. So Hadoop is not built using a very expensive server, which comes with RAID and this and that. So RAID is RAID kind of systems are very crash free, which has a backup kind of plan. So Hadoop clusters are built with cheap commodity hardware. Otherwise, the economy will go out of control. Like IBM server comes with 20,000 euro, or say, let's say 20,000 euro, 2 million NOK, 2 million NOK. So the company is not going to build an Hadoop on 2 million NOK system. They would like to have something for 2,000 NOK. One server they want for 2,000 NOK. Like we can simply assemble a system by getting 16 GB RAM, very cheap RAM, or 200 GB hard disk, or 1 TB hard disk, very cheap hard disk, which is SSD drive, hard drive, not even a solid state drive. And very cheap configuration. They are connected with LAN, not inexpensive one. So cheap commodity hardware are used. The Hadoop is not crash free. Means in Hadoop cluster, the system is going to crash. If you are building 30,000 machine at any point of, in any day, there will be 5 to 10 will crash. Now, imagine we are talking about big data and we are to keep all the data. We have to do a real-time processing. Every data is important. And at the place, the system is crashing. So no one is going to trust, right? So how does the reliability come into the picture if a node is crashing? Let's say a data node where data is stored is crashing. And now it's okay. But imagine if master node is crashing, which has information of where all the data is there. And now once you store the data and master node crashes, what will happen? The information of all this data stored in a different place will be gone. But don't worry, Hadoop has the disaster recovery also arrangement, and also how it manages the reliability. So in Hadoop, by default, the data are kept at 3 places. For example, if I have one data, it will, first of all, it will be divided. Let's say I have 12 terabytes of data. So 4 terabytes of data will be kept in one node, another will be another node, another will be another node. And then there will be, so that if one crashes, then part of the data, it's not that everything is crashing. And then these nodes will be in a different places. That means it's not like they are kept in the same rack. They can be kept, they are kept in a different rack. And apart from that, there are 3 replications are there. So the number of default replication of every data is 3 times. That means if you are storing 4 terabyte of data, then there will be another backup of 8 terabyte of data. Means 4 terabyte in one place and another 4 terabyte in another place. So that's how, if one crashes, the chances that the data we can get. So in that case, if one crashes, the master will not able to know that this node is not responding. Then immediately it will refer that, okay, for this data, refer to the replicated node, and that will become the node to access. And then it is going to create another node where the replication of that data will be there, so that at any point of time, 2 extra copies of data is there. Now, what if a master fails, right? Master can be failed, then everything will crash. So to handle that, there is another node which are kept in a backup, which is actually serves as a master node, but that is a backup master node that at any point of time, one active master node will be there, and backup node is kept. If master node fails, then this backup master node will become the main master node. So that's how it maintains the reliability and crashing of the technology. Like Hadoop, even if we want to build, like we didn't do this colloquium, like built an Hadoop cluster in our own lab, like install in 4 different systems, and then make one node as a master node and other node as a the data node, and then do this Hadoop whatever activities available. So that was first of all not the focus of our cloud and big data technology course. Means this course is not a networking or server administration course. So I didn't actually make that colloquium where you go and actually set up. Like if I ask you, go and install Ubuntu system, that is not focus of this course. Okay. But anyway, you understand that installation of software is not hard. You can do it. And then connecting, and this software, this Hadoop platform comes with configuration settings by which you can make the one as a master node and other as a name node. In future, if you work in a company, then or maybe in some other course like distributed file system or other advanced database system, if they are conducting this lab, you may learn how to make a Hadoop cluster and make it working. So in Hadoop, if someone asks you, what is the basic Hadoop? What is the basic requirement of Hadoop architecture? So for Hadoop, there are three basic requirements. One is Hadoop distributed file system, which is called HDFS, where data is stored. And then second is Yarn, which is a resource manager. And third one is MapReduce, which is for processing. So if you think about this data node and all this, here only the data is being kept, stored. Now, it cannot do processing, you know. It is only kept for, HDFS is only kept for storing the data. It is not for processing the data. For processing the data, there is another things is needed, which is called a MapReduce or other kind of tool. Now, I was telling you that there are like if master node fails, what will happen? There is another default master node is there, a backup master node is there that can be made a master node. Or if let's say I get a data of like default block size is 128 MB, and now I got a file of 300 MB, right? Now the Hadoop system will say that there is one thing, if you want to store it, that will say that it has to be divided into three parts: 128 MB, 128 MB, and remaining 44 MB in other places. So 256 and 44, 300 MB. So now it will say I need three places to store. Now who is going to say that where the data is available and where we can keep? So that is the task of Yarn. It is a resource manager. It is going to have the knowledge of what are the resources available and which resource is active and not active and where to keep it. It is not a master node, but it is a resource manager. So for Hadoop basic, you need HDFS, Yarn, and MapReduce. So if you install a free Hadoop from Hadoop platform, then these three things will be minimum needed. If you are installing a Cloudera Hadoop platform or Hortonworks or MapR, then you may get additional other tools also. We will know what are the other tools are there, but by default, these are the three things which comes as a Hadoop architecture. So in Hadoop, there is a master node, which is a name node, and the other nodes are called data node. And here I'm taking a 4-node or 4 cluster as an example, where your data will be kept. Now, this Hadoop distributed file system, it is a system where only we can store the data and data of any format, whether it is a SQL data, whether it is a structured, unstructured data, XML data, log file data, text data, flat file data, JSON data, every data, it can be stored. So storing is not an issue. But there is a big limitation. You cannot edit the data in HDFS system. Means directly on HDFS system, you cannot edit the data. You are talking about heap storage. Heap storage, I have to check whether Hadoop is a heap storage thing or not. I will give you, we can remove the data. Okay, so in Hadoop, in HDFS, I'm just talking about HDFS, where we have HDFS, Yarn, and MapReduce, only three things. So assuming that these three things are there, so in HDFS, we can store any data, but we cannot edit the data. You have to imagine that one transaction data, the Hadoop is not built to do handle one transaction. That okay, Dilip, I want to access the data for Dilip, and I want to change his address from my CRM system. The Dilip is my customer, and I want to change the Dilip address from Singapore to Norway address. The HDFS system is not built to do a single transaction kind of data. So we cannot edit the data in HDFS, but we can append the data. Let's say if we want to add more data, append is easy, that you just add at the end of it. But going inside and editing it is not. Because in HDFS, specific seek is not possible. If you want to access, okay, the value number 10 in a table, or ID number 10 I want to access, this is not possible in HDFS. It is done in different way, means you can do it in a different way, but directly in HDFS, this is not there. And HDFS is actually built to handle really a large data and do the batch processing. So this MapReduce can do the batch processing of your data. You have learned in colloquium what is a batch processing. So MapReduce means I will tell you how to handle the one single transactions in HDFS system or other thing. But taking the property of HDFS, we cannot edit a data in HDFS system directly. We can append it. One way is possible is that we pull the data from HDFS and we make modification of the data. Means basically we make a copy of the data from HDFS. We make the modification there, and then we put it back to the HDFS and delete the old data. So that is possible. Means we copy the data at some other place in some other system, and there we do the edit, and then we put it back and edit the old file. In that way, we can make the changes. But directly on the storage device, means or directly on the HDFS file system, edit is not going to be possible for one transaction or one particular data. Seek is expensive. See, in even with the Linux or Ubuntu or Windows system, seek means I want to search one block size, or I want to search one block. So if we see in our hardware system, one seek operation is basically 8 byte of data, means that much we can access. So if you want to, let's say 128 megabyte, and in the 128 megabyte, you want to do a seek operation, it is very expensive. Computationally is very expensive, and it is directly not, it is not designed to do it directly. There are other tools are there by which we can do it, but not directly. What Hadoop is meant for, it is not meant for handling the real-time transaction. Means we want to really do a real-time transactional data, each and every data we want to do. It is not actually, the industry didn't demand that. So it was meant to do the analysis on the data. Means we want to analyze the data rather than modify the data. Means it's like if we want to do a makeup and change the clothes and etc., that is what it allows. But if you want to change me, like putting hand into head and head into hand, that is not possible. So that is, HDFS is not meant for that. It is meant for analysis of the data, and really a big data and large data, petabytes of data can be analyzed with a reasonable amount of time. All the limitation which HDFS has, as I was telling you, that we make a copy of the data and do the editing of the data there and then put it back and delete the old file, that is a processing step. Means all the limitation of Hadoop distributed file system is possible, but those all limitation we can overcome by processing in the processing step and by using a different tool or different way. But if we have to understand that it is meant to handle really a large data, And primary interest was that can we handle how to do analysis on large data, which was actually not getting possible with traditional system, and also handle the different types of data, structured and unstructured, both type of data. I hope it is clear. So removing the data is possible. If you put any data in HDFS, you can delete the data. Okay, the whole data you can delete. But editing on the HDFS system is not possible. There are different ways to do it. So the rule is that we access the data, means take the data, edit the data, restore the data, and delete the old file. This way we can edit the data of HDFS file system. So basically we access it to another place, then we edit it, then we restore it and delete the old file. So that is the way we can do it. Practically, people don't want to do one-by-one transaction in HDFS system. It is meant for more analysis of the data and getting more real-time activity from the data coming to the HDFS system. So if you want to see the Hadoop architecture, right? So Hadoop architecture is basically, I was so basically the users are here, and the users who want to work on the Hadoop system or any data is coming. So there will be a gateway system. This gateway system via which it is directly connected to the Hadoop structures. Why it is? Let's go back here. Polyglot, right? So think, I am running this Parabank, okay, or let's say ICICI Bank, which has a customer of around 350 million customers are there. 350 million bank accounts are there, and there are many commercial customers are there. Do you really think they will allow directly access all this thing? They will not. No matter what is the requirement, they are not going to allow any consultant or anyone to work or anything to directly access their thing. The only way is that you make a copy of it. Make a copy of it and do whatever. We are not going to give you the access, and that also not directly by any computer. So there is a gateway. There is a gateway there, and that the company will trust, and via these gateways are directly connected to Hadoop clusters. And whatever command we run from here, let's say we say disk copy, okay, or disk copy, then the command will go here and it directly will run on it, and then it is going to done that operation. So it is done via the gateway. It's not an API. If you actually make Hadoop in your own way, let's say we build an Hadoop cluster in our own lab, then we can directly access it. But in company, they don't allow to directly access it. Company are very, if I'm not talking about security and etc. of this, but company wants to keep their system with more security. So they have created this gateway where what you call it, if you are accessing, let's say using a Kafka. So Kafka is a tool which can access, which actually takes the data, and the real-time processing of data can be possible. Or Scoop. I will tell you a little later what is Scoop. So a Scoop is basically take data, keep it. Take data means Scoop is like a barrage. The moment something comes, it is simply going to let it pass without a gate, and it doesn't affect the operation of existing system. So it is directly putting into HDFS. So if you think from point of view, company have not overcome all this platform. They still want to keep it, but they want to do more of it. So they have moved to Hadoop, but still they are using all these things now, and they don't want to give access to it. So there are solutions available where this kind of gateway has been created, and this is I'm talking about the what happened in the company. So you are accessing from here, you are running a client, and you are getting connected to a gateway, and that gateway will run whatever command you give, it will run here. But the same thing, if you are directly in access to it, then rather than going via the gateway, you can directly run on it. So it is not an API, it is directly you can run on Hadoop if you have an access to it. But in industry, it doesn't happen with that. And if you see that there is a name node, which is actually master node, and there will be another node, which is a job tracker node. Yes, it's a similar to API, but it doesn't directly integrated in the Hadoop. You do it via another tools. So if you really go to the industry, you come to know that there's a tools and tools and tools and tools. It is a very different world. Okay, so lots of security and privacy is a concern, data safety and all this are there. So there are many firewall, or you can call it many layers of walls are there, and via one wall to other wall, all these things happen. So you can see that there's a rack on which one master node is there, and there is another rack where this job tracker is there. Then there is a secondary name node, which is a auxiliary master node. If this crashes, then this will become a master node. And then there is another node where client is connected. Then there are many data nodes are there, so racks and racks, lots of. So if real world Hadoop architecture will somewhat look like this, and architecture design can changes depending on what I will later on, I will show you a case study of a bank, how the Hadoop architecture look like in that bank for a particular example case study and or examples of case study. Okay. Is that okay? Shall we move? It's interesting actually. I when I was studying and finished my bachelor in 2003, and then I went to work in IBM, and it is a whole new world. I used to work on one computer that is also in the back in days. I did not have my own computer because computers were expensive. We used to access the computer center in our university. Computer centers was there. There was computer, and also a central computer center was there where lots of computers are there, and then departmental labs are there where computers are there, and also hostel, some common computers are kept where we can use it. But when we went to work in a company, we were always behind a wall, always via a API. And that time the virtual desktop came up, the thin client or thin machine where you only have a keyboard and a screen. You don't ever able to see where is the machine. You only get the keyboard and a screen, and via virtual connection you connect to the system, and there also with lots of access control are there. You are depending on your access level, you are able to handle certain thing, or certain you think you are not able to access it. And if you try to access certain thing, the alarm raise up, and immediately manager will be reported that this person is trying to access something which he is not authorized to access it. One time, if it does happen by mistake, it doesn't set alarm. If let's say I try to access 3-4 times, and every time it is giving you do not have access, then the mail will go to the manager that tell your person that you don't have access. It is unauthorized access is happening. Anyway, so moving forward, so to give it in writing, so in Hadoop architecture, the name node basically stores the metadata for files. Means remember we had this file, right, where the distributed here and distributed here and distributed here, but then the metadata will be kept here. That where are these? So this master or name node will have the metadata for files like directory structure for typical file system. And the server holding the name node instance is very crucial. So usually they create the name node with a higher end server, which is little more robust than the normal commodity thing. But with the normal commodity also, you can create a name node. That is nothing, no harm in it. It also keeps the transaction log for the files for delete, add, but it does not use the transaction for the whole block or file system. It only keeps the metadata. Means it's not going to keep the copy of the data. It is only going to keep the metadata. Where are the files and who has accessed it? When was it deleted? What has been? When was it added? All this metadata will be kept in the name node. It also handles the creation of replica block when necessary. Let's say one data node failed, where then the name node, which is a master node, will come to know because the heartbeat is not there. You can call it. Heartbeat is not there. So it will say, okay, this node has failed. Okay, this node has a data replica here. Okay, recruit another name node, another data node where copy the data so that we can have a replication. So default replication is 3. That means you have 2 copy. By going into the setting, we can make it 2, or we can make it 4, we can make it 5, or we can also make it 1, but then it is not going to be the fail-safe system. If a data node crashes, then we cannot make it 0. Okay, we have to have 1. So settings we can go and change. So now comes this data node where actual data is stored. In data node, we store the actual data, and it can have all the different kind of file system like ext3, ext4, HDFS, and it notifies the master node, which is a name node, that what block it has. So let's say we have a 300 megabyte of data, right? And it has been divided into 3 places. Let's say 120 MB, 120 MB, and then remaining 44 MB. Okay. Now, the first block maybe has a name block 1. The second has, I'm just telling it symbolically, block 1, block 2, block 3. So it will notify the name node that what block I am containing. And the name node, master node, will replicate the block into 2 times into local rack and 1 time somewhere else. So in the same rack, it is going to have 2 copy, and in another rack, it will have another copy, so that if this whole rack crashes or power failure happen, then it has a copy elsewhere. Okay. So in summary, Hadoop is basically a distributed system with some centralization via the name node. Main node of our clusters are where most computational power and storage of the system lies. So that means where in the main node is doing a lot of operation, right? So where the computational power more, I was saying you that usually the main nodes are being more robust one, and it has been because it has to handle computation power. So I think like we can go up to 5,000 servers of a Hadoop cluster with one main node. Now, to handle the 4,999 system, the main node has to be a stronger one. It is a convention, it is not a requirement. If we are building, let's say, I give an example. I have a desktop system, okay, normal desktop, basic one, bought for 2000 NOK. And in 2000 NOK, let's say I got a system, 16 gigabyte of RAM, and 500 gigabyte of hard disk, and let's say 4-core system. Like that, I can buy 5 of them. So 2000, 2000, 2000. So 10,000 and okay, I bought the 5 system. And out of them, I installed Hadoop client in 4 places and Hadoop server, Hadoop system software in this 5 system. And then made one system as a name node. So having the same configuration with a very low end, still we can make a name node. But now imagine if I keep on adding more system, and this particular system only has 4 core. Until 4 core, I am handling 4 system is okay. Now I raise it to 50 more nodes. Now all this 50 node will ask for request that now what should I do? I have to copy this. Where should I copy? Now this has to handle, it has only 4 core. In that scenario, the delay and the performance issue will come. So it is a convention that the main node will have more computational power. But if we are having 4 or 5 system, or even we can make a Hadoop cluster with 2 systems. One will main node, and another will be the data node. Is that okay? Thank you. So main node will also run the task tracker, because it has to also be sure that task given to it has been completed. And so main node will say, okay, run this task, and the map reducer is, we will know next week what is map reducer. So map reducer will take the task, and it will convert the job into a processable format or map reduced format in a batch processing format, and it is going to run it. And data node is used to store the needed block, and it is usually stored as closely as possible. As you saw, that the replication blocks are kept within the same rack, so that closer it is, the faster will be the access time. And because these Hadoop clusters are built on a very cheap commodity hardwares also, like network connection devices are also not very high speed, or like 100 gigabyte, usually not 100 Gbps or 1 Tbps, not like that kind of connections are kept. It is simple LAN network they are connected. And what the LAN network or bus can handle, not even a bus, it is a basically a LAN network. So like 100 Mbps connection, it can handle usually. We can have a more robust system. There is no protocol limitation that you cannot use high-end hardwares. So there are central control nodes are there which run the name node to keep track of the Hadoop file directories, and job tracker is to help to dispatch where the compute task will be there, and it also tracks the task. Hadoop is practically written in Java, but so if you want to run this MapReduce program, you need to actually use a Java to make a MapReduce program, and that is one reason that I was not able to make many programming-oriented tasks, because the moment I want to make a programming-oriented task on cloud and big data, I have to go to MapReduce. And you have, if you want to make a MapReduce program to run on this big data platform, then the Java knowledge is needed. And at currently the student who are coming, you only know Python. So I won't ask you to learn Java and do this MapReduce thing. But let's say if the same course is conducted in a master level, I will conduct in a different way. With the same lecture note, I will conduct in a different way with a different lectures I will be giving. Okay, but HDFS also support Python and Ruby on Rails programming language. So Hadoop storage is basically the whole is Hadoop. Okay, if someone say Hadoop, 3 things are needed. You need HDFS, Hadoop distributed file system. You need yarn, and what else you need? Map reducer. Okay. So in Hadoop HDFS storage, you have a name node, and there are one or multiple data nodes will be there. And as I was saying, there will be a gateway machine which is directly connected to Hadoop cluster, and you access the gateway machine, and via the gateway machine, you are allowed to access the Hadoop cluster. if you work in a company, but that is not really a requirement. You can directly access via one of this system, like you can directly access the name node or data node if you are yourself building it. But in general, in a company, you access via gateway machine. So I was saying that if you have a 180 MB file, right, and let's say assume that I define the block size, maximum block size available is 120 MB. I defined 64 MB as a block size. Configuration is kept. Having a smaller block size can be sometime faster. So 64 MB I kept, and I want to keep this 180 MB data. So it has to be divided into 3 parts: B1, B2, B3. And then one will be B1 in the one data node, the other will be in another data node, another will be B3 will be in another data node. So one file is divided into 3 places, and then the replication will be there. Default replication is 3 times. As I say, the data redundancy is there, but the requirement, it is a large commodity hardware system. So replicating in multiple places is was not considered so big thing. The aim was that can we handle the big data with reliability and fault tolerance, so the industry can sustain the replication. But in version 3, they have removed it. In version 3, we do not have replication. They are using a different technology called erasure encoding. I'm not going with an erasure encoding in this, but in version 3, they have removed it. Assume that we are actually discussing Hadoop 1 and 2, and where the replication is there and data redundancy is there. But then with data redundancy, it is also giving the advantage of availability and handling the big data. So it was acceptable for the industry. So this data replicated will be, the B1 will be also be in another system and also in another system. And then B2 will be also here and here, and B3 will be 2 other places. So if one fails, the other copies are available. Okay, but the name node will have immediately access to, let's say you want to access this file and you want to run a movie, which is 180 MB size. So immediately it is going to have access to, it will have the where is the main copies there. So it is directly going to access, which is a closer one. So B1 and B2 and B3 it is going to take. If they are closer like B1, B2 and B3, then it is going to go here. So faster, which can be loaded. And as I said that this copy was a command. There is a company which is actually built for fault tolerance of our Hadoop system. So Windisco is a company which they make they came up with a solution or a software whose only task is to do this fault tolerance in the Hadoop system. So that how the name node will be recruited, how the passive name node will be there, if one data node gets crashes, where will be copied, all these things. Though Hadoop internally it has yarn and other kind of tools, but to have more reliable thing, the Windisco came with its own solution. The Windisco is a one company which only became successful by doing this fault tolerance. So this Hadoop was in so much demand that with one solution, a company survived, became few $1 million. So with the time, the more and more requirement came up. The Apache also came up with Oozie to manage the server-based workflow, to scheduling the system, to manage the jobs given into Hadoop. So Hadoop is a batch processing where you send the data in a queue and the processing is done. So Oozie came up. People developed the Oozie, which actually manages the workflow. And now you have a Kubernetes. So now Hadoop is getting taken over by Kubernetes and Apache Spark. But still, a lot of companies are still using the Hadoop. Oozie provides support for different types of action, including Hadoop, MapReduce, HDFS, Pig, SSH, email. Other actions can also be programmed. but Hadoop is actually FIFO system, first in, first out, and queue-based scheduling is there. So you send the job in a queue, Q1, Q2, and whichever come first will be given processing first by default. We can change it. So there is a Cloudera manager. It is somewhat very similar to what you see in Azure, that you have different kind of thing, and there is HDFS, Hive, Impala, Hue, Kafka, Oozie. All these things are there. And you can see the cluster, how clusters are getting access in 30 minutes, 1 hour, 2 hours. Those charts are also available. How many systems are there? If you go to the Cloudera system and you have an admin access, you can see what role and what is they are running, and how many last heartbeat was when. So it was 14 seconds ago. This was 271 milliseconds ago. So that is the most recent one. And what is the disk usage? You can see that this is a Hadoop cluster. One is only 50 GB. Other, and with the physical memory of RAM is 6 GB or 8 GB. And this one is 16 GB and 560 gigabyte of disk storage. So, and if you want to see the replication, by default set is 3. And block size also can be changed to, by default, 128 MB. It can be changed to other thing. So that was a Cloudera, and I was still talking to you about the rack, right? Okay. So racks are basically this. So, and this was amazing when I first saw a server of this size. In university also we had a server, but not like this. It's racks and racks, and the floor is only the server. It was not like this. So you can see this is a gateway machine, and via this you are getting access to the racks. So coming back to it, case study, right? So assume that I have this bank, let's say ICICI Bank, or you can even name it Spara Bank also. So now they have this customer relationship management data in a MySQL format, and they have their banking transaction in Oracle, and then this XML and JSON, all these things are there. Now, they want to put it into HDFS, Hadoop Distributed File System. How they are going to do it? To scoop, using a scoop, it can directly dump the data into HDFS. So scoop is basically take the data and dump it, take the data and dump it. So this is a CRM data, customer relationship management data. Company may allow via the scoop, is another system on which scoop is installed. And this scoop system can directly copy the data to here to here. Customer relationship data doesn't change that much, so it can, it does not have too much change requirement. But the banking data, the bank wants to use the Hadoop system, but they won't allow direct access to their own system, which is their main core banking system. So what the solution came up, that there is another tool is there which detect the change detection. So it detects the change happening here, and that change is actually fed into via the Flume to HDFS. Now, Flume is a tool which is actually point to point, means I take and I push, I take and I push, I take and I push. And why the need of Flume is there? Again, they cannot give access directly to anyone. So you have to get via this, and Flume doesn't store a data. It is basically like a captain ball. You get a ball and immediately try to pass to other, because music can stop and you are out. So Flume is point to point, and it can actually directly dump the data immediately. But it doesn't do the any kind of real-time processing. It doesn't happen on Flume. It is just to push the data into HDFS system. And Flume is an environment, one of the member of Hadoop ecosystem. But banking data also they want to put in HDFS, and but they cannot give direct access. So change detection tool is there via which it goes to Flume and via which it goes to HDFS. So you can call it a micro batch way it is getting pushed, not a single transaction going, let's say 1 second, 2 second data going, not one transaction is going in HDFS. Now, the requirement is that we have to do the processing. And to do the processing, we need something called Kafka. So Kafka is another a tool in Hadoop ecosystem. So Kafka can keep the data by default for 7 days, means and Kafka runs on independent system. It is not on Hadoop cluster. Kafka is independent of the Hadoop environment. So it is a in-memory execution. That means a Kafka system will require a large RAM space and compute power, but it can do real-time processing of the thing can happen. Let's say we want to analyze the mood of, let's say, a new what is happening in a social media, and this bank want to analyze the mood of the thing. Or let's take another example, like a match is happening, let's say a soccer match is happening, and want to predict who will be the winner, etc. So we want to build a real-time system which can predict it. And if we go for a normal, this kind of big system, which will not allow to do it, it is to store the data. For those kind of environment, the Kafka comes into picture, and which actually gets the data from various platforms. And then it also has the in-memory execution, and this particular thing can be fed into Spark streaming. So Spark streaming is a part of the Apache Spark, or you have used a Databricks. So Spark streaming, you can do a real-time data processing. Means not real-time means not every transaction. It is a micro batch processing. Means 2 second, 1 second data. In 1 second, 2 second, how many transactions happen can be done using Spark streaming. And if any domain which require really a single transaction, there are other solutions available. But usually with 1 second, 2 second of data, this can be done. So imagine you want to build a fraud detection system. Means you make a transaction and a fraud happens. So how to do it? So if you want to really do a single transaction, Storm are used, but Storm is actually currently out of the market. Flink is there, but Flink is also going away. Everything has been taken over by currently Spark. So now you want to build a fraud detection system of a banking transaction. So real time, how to go through millions of transactions to actually tell whether this was a fraud or not a fraud. So what has been done, you have this HDFS data, past data stored here. And using this data and machine learning can be trained. And you have used MLlib in your colloquium, or there can be Mahout. Earlier was Mahout, but in Spark, you can use MLlib. And this MLlib has been fed with the past data, and the machine learning is trained. So one transaction came, this Spark, using the Spark streaming and using the MLlib, it can predict whether this transaction was fraud or not. And immediately you can get a message, or your card has been used this place or that place, and it may be a fraud. Or it can notify the bank that this is not the usual habit of this person. But now you also have structured data. So the Scoop can take the CRM data and it can go to Kafka, and Kafka can send the data to Hive, and Hive is meant for SQL processing on HDFS. So if you want to do the SQL kind of processing, SQL query, etc., Hive is used. So now Hive will send the message to MapReduce, and MapReduce will convert for batch processing for HDFS. But you don't write, if you want to write an MapReduce program, you have to write in Java, but using Hive, you can write in SQL, and Hive is going to send it to internally MapReduce, and it is going to convert automatically into MapReduce format. So you don't have to worry about. There was Pig also. Pig is not been used more recently. But then there are other tools are there like Impala, Hawk. Impala is by Cloudera, Hawk, and Presto is by Hortonworks. But now all three are by Cloudera because Hortonworks has been taken over. There are other tools like Rail and Phoenix for different kind of needs. Those tools are there. But HDFS has its own file system which called HBase, and that can handle the structured and unstructured data. So in our course, we practically going to understand the yarn, MapReduce, and HDFS. All these are part of the ecosystem of Hadoop. And if you want to take a nutshell of an ecosystem, so there is this enterprise data warehousing is there, then there are connectors are there, and on top of it, this business intelligence applications are there where it can Tableau can be there, but then this data warehousing can get connected to data access framework, and on that Hive, Scoop, Pig can be there, and that went down to data storage framework HDFS and MapReduce data processing framework, and that goes to Java virtual machine and operating system Linux is there, and that is backend the Hadoop hardware is running. So this is in general the Hadoop ecosystem, and I hope in a short time you had an idea about how the big data world is actually handling.